Hello students, today we begin one of the most important chapters in physics, mechanics, motion, force and equilibrium. In this first session, we will understand the motion of objects, their velocity and acceleration, and the 3 Newton's laws of motion that describe how and why things move. An object is said to be in motion when its position changes with time compared to a reference point. If its position does not change, the object is said to be at rest. Example, when you sit inside a moving train, you are at rest relative to your seat but in motion relative to the trees outside.
Sir, can distance ever be less than displacement?
Good question. Never. Distance can be equal to or greater than displacement, but not smaller. To describe motion, we use two quantities, distance and displacement. Distance means the total path covered. Displacement means the straight line path between the starting and ending points. Distance is a scalar quantity because it has only magnitude. Displacement is a vector quantity because it has both magnitude and direction. Example, if you walk 3 kilometers east and then 4 kilometers west, your total distance is 7 kilometers, but your displacement is only 1 kilometer toward the west. Speed and velocity. Speed tells us how fast an object moves. Velocity tells us both how fast and in which direction. Speed equals distance divided by time. Velocity equals displacement divided by time. If a car covers equal distances in equal intervals of time, it has uniform velocity. If either speed or direction changes, the velocity becomes non-uniform. Example, a cyclist moving around a circular track at constant speed has changing velocity because the direction keeps changing. Acceleration shows how quickly velocity changes with time. It is calculated as final velocity minus initial velocity divided by time. If velocity increases, acceleration is positive. If it decreases, we call it negative acceleration or retardation. Example, a car's velocity increases from 10 meters per second to 30 meters per second in 5 seconds. Then acceleration equals 20 divided by 5, that is 4 meters per second squared. Equations of uniform acceleration. When acceleration is constant, 3 special equations help us connect displacement, velocity, acceleration, and time. 1. Final velocity equals initial velocity plus acceleration multiplied by time. 2. Displacement equals initial velocity multiplied by time plus half of acceleration multiplied by time squared. 3. Square of final velocity equals square of initial velocity plus 2 multiplied by acceleration multiplied by displacement. Example, a stone is dropped from rest. Here initial velocity is 0, acceleration due to gravity is 9.8 meters per second squared and time is 2 seconds. Displacement equals half into 9.8 into 2 squared equals 19.6 meters. So in 2 seconds the stone falls about 19.5 meters. Newton's laws of motion. First law, law of inertia. A body continues in its state of rest or uniform motion in a straight line unless acted upon by an external force. This property of resisting change is called inertia. Example, when a bus starts suddenly, passengers jerk backward. When it stops suddenly, they lurch forward. This happens because their bodies resist a change in motion. Second law, law of force. This law connects force, mass, and acceleration. It states the rate of change of momentum of a body is directly proportional to the applied force and occurs in the direction of that force. We express it as force equals mass multiplied by acceleration. Example, if an object of 2 kilograms is to be accelerated at 5 meters per second squared, then force equals 2 times 5 equals 10 newtons. Another practical example is catching a fast ball. Moving hands backward increases time, reduces force, and makes catching safer. Third law, action and reaction. For every action, there is an equal and opposite reaction. Forces always appear in pairs, acting on different bodies, equal in magnitude and opposite in direction. Example, when you walk, your foot pushes the ground backward and the ground pushes you forward. When a gun fires a bullet, the bullet moves forward and the gun recoils backward.
Sir, if action and reaction are equal and opposite, why don't they cancel each other?
Because they act on different bodies. The action is on the bullet and the reaction is on the gun. We learned that motion is described using distance, displacement, velocity, and acceleration. We studied how acceleration is calculated and how three equations of motion connect all these quantities. Then we discussed Newton's three laws: inertia, force, and action-reaction. In the next class, we'll explore force, momentum, impulse, and equilibrium. See you in the next session. Jai Hind.